Alright, so in part A of this example problem, we had two positive charges. So here's our two positive charges, and then we have point A, point B, and point C. So we need to do our vector addition. So let's start with point B here, and you'll notice that the top charge has a filled line and points in the negative y direction, and the bottom charge has a filled line and points in the positive y direction. So they actually cancel each other out, so you actually get 0 here. At points A and point C, we get something a little different. So this is a negative x, this is a negative x, but this is a negative y, and this is a positive y. So the y components cancel each other out, and we find that the filled line points to the left. And on the other side, this is positive x, so those add together, but this is negative y and this is positive y, so they cancel each other out. So we get that the filled line points to the right. Alright, in part B, we have now switched to both charges being negative, and we're going to see something very similar, just in a slightly different direction. Where in the center, we have positive y and negative y, so once again, they cancel each other out and we get 0 here. But when we look at the two sides, if we look at point A, we have positive x, positive y, and then positive x, negative y. So the y components cancel each other out, and now our field line points to the right here. And on the other side of point C, we have negative x, positive y, negative x, negative y. So the y components once again cancel each other out, and our field line points to the left. So very similar to positive charges, but the field lines end up pointing in opposite directions. So now we switch to one charge being positive and one charge being negative. So in the center, we see that it's negative y, so our net electric field is going to point downward in the negative y direction. When we get to the sides, we have negative x, negative y, positive x, negative y. So we see that it points downward. And I'm able to do these cancellations out because the charges are identical. So we're assuming it's a negative charge and a positive charge of identical, essentially magnitude of charge, even though charge isn't a vector, even though one's positive and one's negative. So that's why I'm able to do this vector addition like this, because the charges are identical in strength. Alright, and then on the right, we have positive x, negative y, negative x, negative y. So once again, we see the x components cancel out, and then our y components are both negative. So you can see here how you can use the direction of the field lines to establish what direction at a particular point that the field lines and the electric field are going to be pointing.